Here, buddy, here's a quick video on compound inequalities. So what a compound inequality means is it's basically a set of two inequalities, like you see right here. You can write x greater than or equal to -5 and x less than or equal to 7 as one big inequality. So let's see if we can put that together. So we know it has to be greater than or equal to -5 and less than or equal to 7. So we're going to start with our lowest number. And we know that x is greater than or equal to it. So we're going to open up to the x. We also know that x has to be less than or equal to 7. So we're going to make x less than or equal to 7. This is a compound inequality that would be an and type problem. And would mean that the x fulfills two different things, both being greater than our smallest number or equal to, and less than or equal to our largest number. So that's what a compound inequality would look like. This new thing that we created. That's an and one with the x in the middle. So next part is how do we graph it? At -5, which is our lowest point, we have a closed circle because of the or equal to. And at 7, we also have a closed circle because of the or equal to. Now, the x falls in between, and it also says that x is greater than -5, but less than or equal to 7. So, as you can see, if we continue to extend our lines, they'll meet up and connect in the middle. And that's an and inequality. So, what it's saying is that any number within this range from -5 to 7 inclusive would be a solution to this compound inequality. Anything on the outside greater than 7 or less than -5 would not work. Okay. So what we're essentially saying here is x is greater than or equal to -5 and x is less than or equal to 7. So x is between -5 and 7 inclusive, basically what I just said restated. So the next part is interval notation. So let's go back and look at our graph and try and do this in interval notation. What we remember from interval notation, or we should remember, is that we start at our lowest number and go up to our highest number. So our lowest number is -5, right? You can see it right there. So that's where we're going to start, and it's inclusive, so we're going to have a bracket. And we go up to our largest number. In this case, we're stopped. We're stopped at 7, so we're not going to head off to infinity, because this is stopped at two places. It starts down here and ends right here. We're starting and ending at numbers. Therefore, we cannot have infinity at all in these compound inequalities that have an and. So the one where the x is in the middle should be two numbers for your interval notation. Notice this also got a bracket because we're also or equal to. So let's practice with another problem. So we have to solve this one first, and then we can graph it, and then we're going to write an interval notation. So we have -6 less than or equal to 3x is less than 15. So if you solve this normally, and you just looked at it like this, you would divide by 3. Or even this, you divide by 3. So you want to do the same process. Just divide everything by 3. The middle by 3, the right side, and the left side by 3. So that we're left with 1x, and then we have -2 less than or equal to x less than 5. Again, notice the x is in the middle, so we're looking at an and inequality, which includes numbers greater than or equal to -2 and numbers less than 5. So let's try and graph it. At -2, we have a closed circle, because it's or equal to. At 5, we have an open circle, because it's just x less than 5. So now we just connect the two dots. And that's it. That's how we graph this. So when there's the x in the middle, your graph, the line, should be in the middle of the 2 points that you make. For interval notation, we start at our lowest point, which is -2, and we go to 5. Now, this is or equal to, so it gets a bracket for the -2. This is not, so it gets a parenthesis for the 5. Same idea as we always had with brackets and parentheses in interval notation. Same idea with going from our lowest number to our highest number. The only change here is that we no longer are using negative or positive infinity, but that only exists when we have the x in the middle. Soon you'll see an example where that would be changed. All right, so let's try this one. Notice how in the last one, it was set up with our arrows pointing to the left or opening to the right for our inequality signs. This one, same way, but something might happen. So let's take a look at this. Subtract 10 to everything, right? You solve it just like any old problem. So negative 4 is less than negative 2x is less than 4. Now I think everyone can identify what's going to happen next and see the problem. So we're going to have to divide by negative 2. And when we divide by negatives and we have an inequality, we have to flip our signs. So what's going to happen is we're going to have 2 greater than x greater than negative 2. Well, now this is out of the order that we usually use. First off, we're going from greatest to least, whereas we should be going from least to greatest. And we always want our inequalities opening this way. So we got to rewrite this thing. Negative 2 less than x less than 2. We want it to be written in order from least to greatest, making our interval notation and our graphing easier that way. So let's try interval notation. Start at negative 2 with the parenthesis, because it's just a less than sign, and go up to 2, again with a parenthesis, because it's just a less than sign. So we'd be looking at 2 open circles on our graph, connected in the middle. And that's it for the and inequality. So let's try an or inequality. It's a different type. So we're looking at write an inequality in graph. All real numbers that are less than negative 3 or greater than 7. So we have to write this in 2 different inequalities. All real numbers, so we're going to say x, that are less than negative 3 or x is greater than 7. So if you graph this, we have to think about how our graph might look. If it's less than negative 3, we have an open circle going this way. And if it's greater than 7, we have an open circle going this way. Well, that's never going to meet up. So we're talking about 2 diverging lines going in opposite directions. And that's what you get with an or. And they connect in the middle, and or they go off in opposite directions. So how can we write interval notation for this one? Well, it seems a little more complicated, but it's really not. Just take it one part at a time. So if you did x is less than negative 3, well, you start at your lowest possible number, which is negative infinity, because that's where we're headed off to. We're going to go all the way up to negative 3, parenthesis, right? And your other option would be to start at 7 and go to all numbers bigger than 7, which is infinity. And they both get parentheses because they are less than or greater than, no or equal to's. And that's it. Some people you'll see writing a U in the middle here to signify the union, so it could be either this or this. Alright, so this is interval notation for an or one. We're talking about one that's going off in 2 different directions. One's going towards negative infinity, one's going towards positive infinity. So yours should basically start with negative infinity up to a number, and then the next one should start with a number and go up to infinity. So let's try another example of those. So the or ones look very different than the and. They are written as 2 different equations, and there's an or in the middle. The and would be written as 1 with an x in the middle. So we're going to subtract 7 from both sides. Just solve it like you normally would. Negative 2x greater than negative 4. Well, we saw in the beginning that both of these had signs going the same way. And we know the signs need to go different ways for them to diverge. So I'm not surprised we're going to divide by a negative. Which is going to flip our sign and get us to x less than 2. Okay, so we've solved one. Let's put down the graph. 2, open circle, and we're going down to negative infinity. Let's try this one. Add 4 to both sides. 3x greater than or equal to 9. Divide by 3, x greater than or equal to 3. All right, so we've solved for the other one, and now we have to put a closed circle at 3 and go off to the right because it's greater than. So now look at what we've done here. We have all numbers less than negative 2 and all numbers greater than or equal to 3. And it's going to diverge. So last part of this, interval notation. We're talking about numbers that are less than 2. The lowest we can ever go is negative infinity. And that will go up to 2 with a parenthesis because it's not included. It's an open circle. And then we go from 3, which is included because it's a closed circle and it's or equal to, up to our highest possible number, which is infinity. and that's our interval notation for this one. So like I said, the ors should include your infinities in your interval notation. The ands should not. So those are the two types of compound inequalities that we're going to face.